Hello class, I'll be going over a set of answers to these different problems fairly quickly on the next pages. First problem, we're to solve this equation. We're to solve it using the quadratic formula first, as well as any other method we want to choose. So this is the quadratic formula worked out to plus or minus, I forgot the plus or minus right there, but plus or minus 2 root 2. Another way of doing it, I think, is a lot easier, is noticing that there's only one perfect square here. So I'm going to isolate that down. I'll divide by 3 here. I get x squared is equal to 8. X is equal to plus minus square root of 8 plus minus 2 root 2. These are the same answers as we would expect, although this way is a lot easier. Okay, this next question, the key is we're trying to find out how long the ball is in the air. We have this basic equation here. We need to find the initial velocity, the initial height, and plug that in. The initial height is stated as 7. The initial velocity is stated as 90, so we'll just plug those numbers in. Then it says the player catches the ball when it's 3 feet off the ground, and so that's our height. So we're going to solve for t when h is equal to 3. And at this point, I'll subtract 3 from both sides, get it into standard form with a 0 on this side. At this point, I'll use the quadratic equation. Well, before I do that, I would actually divide by 2, just to make the numbers a little bit smaller. But using the quadratic formula, which I'm not showing, we get these two answers, 5.67 and negative 0.044. We cross out the negative version since it doesn't really make sense in this problem. Okay, this next problem here. I'm going to start off by just setting this equation to 65 to find out at what point of time we sell 65 million of these tablets. You know, we're dealing with millions here, so 65 million, I just plug in 65 here. Again, I'm going to set the equation to 0, subtract 65 from both sides, use the quadratic formula. I get two answers, but the negative one doesn't make sense, and I get a number exactly equal to 1. And the problem says that t represents the year after 2010, so 2010 plus 1 is 2011. The next problem asks to find the average rate of change from 2010 to 2012. So 2012 is represented by 2, 2010 is represented by 0. So our average rate of change equation would be f of 2 minus f of 0 divided by 2 minus 0. This is our slope equation. So I just plug 2 into the equation and I get 122. I plug 0 into the equation, I get 17. So then my overall average rate of sales is 52.5. And what it means is this. From 2010 to 2012, sales increased 52 million every year. Lastly, this model doesn't make sense. After a certain point, the parabola itself will go on and up forever and ever if we just strictly used this equation. But we know that realistically that's not true. When a new computer comes out, the sales will eventually fall and it'll come back down. So this only is really probably good for first year or two. Okay, next problem. Next problem has this swimming pool. We know that the area is 400. That's given. So now we're going to set up an equation. This entire rectangle, this height here is 9 plus 2x. 9 here plus x plus x. The distance all the way across is x plus 18 plus another x. So then we can write it in this form here. I'm going to FOIL this out, expand it all out. 400 is equal to this. I'm going to bring all the terms to one side. This is my standard form equation, setting it to 0. I noticed that I could divide everything by 2, so I'll do that as a first step. Then after I do that, I'm going to use the quadratic formula. Again, I get two different answers, and I'll just ignore the the negative number, so my answer is 3.5. Okay, the next problem is an absolute value problem. we cannot deal with absolute values in an equation just like this. We have to kind of have a way of removing the absolute values. So we always break absolute value problems into two different cases. When the inside is positive, when the inside is negative, those are the two cases that we consider. When the inside is positive, we can just merely take away the absolute value signs. We set up this equation here. Again, we bring it into a form where one side is equal to 0. I factor this one. I get x is equal to 6 and negative 3. I check both of my answers just to make sure. So I do get 4. I get 4, which is what I'm expecting to get up here. The other case is when the value inside this yellow stuff is negative. If all of this is negative, to make it, the absolute value turns it into a positive, so we put a negative sign in front of it to do that. In doing that, we simplify it to the next line. The next line, we set everything to 0. Again, this happens to be factorable, and we get these two as our potential answers. I'm going to check each one of these. And these are okay too, because if I get negative 4 inside here, absolute value of negative 4 is 4, and same with this one here. So all 4 of these answers are true answers. Step B, same thing. Again, we need to take away our absolute value. The two cases are when x is positive and when x is negative. So here, you can see that I took away the absolute value bars exactly as it is because x is positive. I go down, I set everything to 0, or I turn the equation into the standard form equal to 0. Factorable again, so I'm going to use the factoring route, and I get two solutions, but only one of them satisfies the initial condition case where x is greater than 0. So 2 is not really a real solution here. X is less than 0. To take away the absolute value, we do that by doing the negative of x, because in the case where x is negative, we have to turn it into a positive by taking the opposite of it. So again, same thing. Turn it into standard form equal to 0. Find out that it's factorable in this case, which is good. Makes it easier. We get our two solutions. But x has to be negative, so we ignore the positive solution too, and we're left with two solutions. X is equal to 3, x is equal to negative 3. Okay, the 75, let me just back it up a little bit. The problem states the following, that we have this equation, A, B, and C are real, and it's saying prove that this cannot be a possible root in this case. So what we're going to do is we're going to kind of use intercept form, concept of intercept form, and create this equation where when we multiply x minus p, x minus q together, we get 0. That should be true if these are indeed roots of the system. So if we were to expand this out, just FOIL out here, add all the like terms, we get down to this, where a is equal to 1, b is equal to negative I, and c is equal to 6. But the problem is this, b is equal to negative 1, that's not real. And that contradicts our initial given that b is a real number. Because of that contradiction, we conclude that p and q cannot be these two different numbers. Okay. Last problem. So in this case, we're given the initial equation. We're also given the maximum height of the vertex. We need to find v0. So let's do some kind of thinking here. We know that the vertex is going to be at b divided by 2a. So that's going to be equal to minus v right here, negative b, so that'd be negative v0, divided by 2a, that's minus 16, so 2a is minus 32. So this here is the t value at which we hit our vertex. So what we're going to do is we're going to plug that value into t, and then we're going to solve for v0 because that's the only variable that remains in our equation here. So we do some simplification work here, and to deal with these fractions, I'm going to multiply by the least common or the greatest common or least common denominator, which is 64. So I multiply by 64, I get down to this. I find out that v is equal to plus or minus 32 root 10. We can ignore the negative version, and we get 101.2 in that case. B is just asking, is it reasonable that at 2 seconds, according to the brochure, that we reach the top of the needle according to the equation? So what we just do is we plug 2 into the equation using 101.2 in here as the V naught. If we do that, we get 100, 1059, 1060-ish. And that compares, I would say, adequately to 1081, which is the height, to the very top. So they're roughly the same. I would say 2 seconds is a rounded number, and this is a decent then model for the height versus time. Okay, that's all the homework questions. Have a good day, everybody.